All right, we're going to deal with the probability of compound events. We're going to skip over single events like flipping a coin where it's 50-50, or rolling a dice where getting a 2 is 1 out of 6, because you've seen that already. So I want to take this opportunity here and make sure that we get a chance to kind of move what you know about this ahead instead of reviewing what you already know again. So if you forget some of that stuff, you might have to do a little catch up in your logic and thinking here, but not too much. So if we think about independent events or dependent, right? Independent means it stands all on its own. Dependent means it has an effect from something else. So if you flip a coin and roll the number cube, would they have anything to do with each other? No. So that makes each of these items independent. Picking a number from 1 to 100 and then randomly picking another number from the remaining numbers. Well, if I go 1 to 100, that's 99, and then I pick another one, I only have 98 choices. So this is dependent, as my probability is going to get different value on the second one. Drawing a marble from a bag without looking, returning it to the bag, so this is key, and then drawing another one. Well, these are independent because we returned the marble there. If we had left it out, then we would have a dependent situation. So keeping the marble out, okay, drawing a marble from a bag without looking, keeping the marble and drawing another one, that makes it dependent. So that's the big difference in 6 and 7. All right, as we set the stage for some of that, we have the idea of a couple of these things. So it's all in text up here. Two events have no outcomes that are common. They're mutually exclusive. That means they're independent. They have nothing to do with each other. And be mutually exclusive events, then here's how it's going to look. The probability of A and B, that means both of these things happening, is 0. And they have at least one outcome in common. They are overlapping events. Okay, so we want to make sure that we're looking for mutually exclusive events. So let's say let's talk about rolling a number cube. What's the probability of getting a 3? Well, that's 1 out of 6. What's the probability of getting an even? That's 2, 4, and 6. So that's 3 out of 6. And are any of these evens a 3? No, right? So that means I make this 4 6, so it's 2/3. And that's what we're trying to get to today with the idea of mutually exclusive. Now, let's say that we do this probability of a 2, so that's 1/6, right? Rolling a number cube, plus the probability of getting an even. Well, that's 2, 4, and 6. So I do want to make that 3 6. But here's the problem. I've counted 2 twice. So I want to take out 1 6. So this is the probability of being a 2 that is even. Okay. So that's going to take us back to 3 6, or 1/2. So that's what we're going to work on in this lesson. So that was kind of all of it all at once. So if there's any chance of the two items actually being the same, then you want to make sure we take it out. So yes, this often deals with evens and odds, or multiples of different things. So we'll kind of step through it again here. Ready? Suppose you roll a standard number cube once. What's the probability you roll an even number or less than 4? Okay, so what's the probability of getting an even number? That's 2, 4, 6. So you're going to see 2, 4, 6. You'll see I'll write those out. A number less than 4. On a number cube, it's 1, 2, 3. So that's 3 out of 6. I'm successful on OR here, so that means I get to add those together. All right, do I have any of these evens that are less than 4? If so, I need to subtract those out. So is there anything in both columns? Yeah, 1 6. That means my final answer is 5 6. So if we're going to kind of set up a little situation where maybe we wager $1 or 2, or not even money, let's say, a Kit Kat, because I love a Kit Kat. Who doesn't love a good Kit Kat? You know what I mean? Then if I can word this in a way that I get an even number or number less than 4, that gives me pretty good odds here that I'm going to have 5 out of 6 of those. So that means theoretically, if we rolled the dice 6 times, I would win 5 of those times. How about that? All right, now those were all or without saying anything about it. So remember, that means we get to add those together. The next one, as you can see, has an and setup. Okay, I don't know why this is written in here twice, but if we have independent events and I need both of them to happen, and we're going to multiply. Okay, so you roll a red number cube and a blue number cube. Okay, what's the probability that you roll a 5 on the red? Well, that's 1 out of 6, and multiplied by a 1 or a 2 on the blue. So that's 2 out of 6. Remember, these are independent events, so I don't have to worry about overthinking it. All right, so that means top times the top is 2, bottom times the bottom is 36. So the chance of this happening is 1 out of 18. Okay, that 1 out of 18. The next thing we're going to start to deal with is making that into its decimal equivalent, okay? Because that's the fastest way to compare how much better of a chance of this happening versus maybe our previous situation. Okay, so this is 5/6. That's almost 1, right? We would agree on that. 0.05 repeating, that's almost nothing. Right? So there's a big transition from and, or from or to and. So I'm going to be careful with those as we look at the next couple problems. So again, trying to really grow your mind on the things you kind of already know about probability in our last couple of sections here. Suppose you roll a red number cube and a blue number cube. Okay, so it's similar to the last one. Probably you roll a 3. Okay, very similar. So probability of 3, that's 1 out of 6. And, so now I'm going to multiply. Probability of an even on the other one, that's half of them, 3 out of 6. So it's 3/36, which becomes 1/12, which becomes, check the calculator here, 0.083 with the 3 repeating. Okay, so I'll take either one of those. Most likely we're going to go to decimals. All right, we're going to roll a standard number cube. Let's probably roll an even or a number less than 4. So part A, probability of an even, that's 3 out of 6. Or, so we're going to do plus, a number less than 4, probability less than 4, remember inequality. What's less than 4? 1, 2, 3. So that's 3 out of 6. But we have a little problem, right? 2 is even. So we're going to have to take 1/6 out of here. So you see a lot of these will look like the same problem, but it's really just because evens and odds, they become kind of the same lingo as we deal with some of these to try and present you with different problems. Let's probably roll a 2. Okay, so probability of a 2, that's 1/6. Or, so or an odd number, that's 3/6. 2 is not odd, so it becomes 4/6 or 2/3. Okay, that'd be what, 0.6 repeating. So we're going to compare any of those for the same thing. All right, 5/6. Let me double check here. 0.83. Okay, so we have some of those. So that means getting even or a number less than 4 is better than actually getting an odd or one of the even numbers, right? So we get a chance to compare some of those things as we move forward here. All right, now we get to have a little more fun with it because now we're going to talk about a spinner. So it has 20 equal size sections, 1 to 20. And the spinner cannot land on both 2 and 5. The events are mutual. Oh, what's the probability that you spin a 2 or a 5? Okay, so a 2 or a 5. So notice what we do is find the probability of a 2, and we're going to add on the probability of 5 because a 2 can't be a 5, right? 2 can be even, but it can't be a 5. So the way they're asking the question is very important here. So that means we have 1/20th is a 2 plus 1/20th is a 5. So it's 2/20ths or 1/10 or 0.1. All right, so let's take a look at the next one. Probability you spin is a multiple of 2 or 5. Okay, multiples. So a multiple of 2 or a multiple of 5, and then we have to check and see if we have any overlapping items. So multiple of 2, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Right, so those are my first ones. So that's 10 out of 20 plus multiples of 5, 5, 10, 15. That's 3 out of 20. Oh my goodness, we forgot 20. That makes it 4. All right, now the last part is, are any of the numbers listed in both of the sets that I have? So 20 is definitely listed, 10 is listed, right? Remembering the multiple of 2 really means even. So 5 and 10 definitely won't be there. So it means I have to subtract out 2 of the 20. So we're up to 14, we're down to 12. 12 out of 20. That makes 6 out of 10, which makes the reduction a whole lot easier, 0.6. Okay, and this will vary whether we'll take decimal or fraction as we deal with anything. Of course, if you can leave it as a fraction, we do have to make it into 3/5 beyond there, but I stopped at 10/6 or 6/10 so we can get the 0.6 really easy. Okay, multiples of 2, multiples of 5. So just counting by 2, counting by 5, saying how many there are, since our spinner goes up to 20 this time. So yeah, we're just trying to work back through a couple of the different ideas. And here's the last one. We have dependent events. So this is taking a marble out of the bag and then reaching in and taking another one without doing anything with the first one. So this means that our second one is going to have that different value for the denominator. So this one's going to get a little more calculator heavy. So make sure you grab that if you need it. All right, 1 freshman, 2 sophomores, 4 juniors, 5 seniors. Top scorers on the school essay contest. All right, how many are there, real quick? 12 to get started, good. To choose which 2 students will read their essays at the town fair, 2 names are chosen at random from a hat. What's the probability of that? A junior? Okay, so probability of a junior. How many juniors were there? 4 times then a senior. So then a senior, probability of a senior. How many seniors are there? There's 5. But how many people are left in the bag? 11. Good. So that means we have 20 on the top. Let's check here, 132 on the bottom. And that's going to reduce. We get 5 over 33. So we get 0.15 repeating. Okay, so there's a pretty low chance, right? 0.15, that's less than a quarter, so yeah, it's not really a big deal. It's a very low chance of that happening. So about 15% is what we're saying. So in 5A here, they're saying, what if it's a senior and then a junior? Would anything change here? Okay, so let's try it out. Probability of a senior, that was 5 out of 12. And then a junior, so that's 4 out of 11. Well, since we're multiplying, there won't be a thing different, right? There won't be a thing different with the order just because that happened. Now, what if we want to make sure probability of a junior and then another junior. So we're going off script. Don't worry about this other part of the problem. So this is the thing I need you to look out for when we look at these events. So juniors were 4. So that's 4 out of 12 times. We know this goes down to 11, but keep this in mind as well. If we're repeating the same class in this point, a junior and then a junior, we've picked a junior. So how many juniors are left? 3. Okay, so if this happens, we need to lower this number just like we do with the denominator because we're saying that they were dependent and they're compounding each other. So we have, we get 12 over 132, and then we'd have to reduce that. or just get the decimal. So we'll take the 0.09, and that's repeating. Okay, so our chances are about 9%, round it to 10% if you want to, so even lower to get a junior and then a junior. All right, so I hope that gives you a nice little breakdown of what we're doing. Let's skip over a couple here, and then we'll pick out a couple for you to answer. So we have 12 equal size selections on your spinner, numbered 1 to 12. We want to find the probability, even or a 7. So how many even out of 12? How many 7s? Since it's or, we just want to add those together. All right, let's go with multiple of 3 or an odd. So out of 12, how many are multiples of 3 or odds? Are any multiples of 3 odd? I think so. So I'm going to give you this part here as well and let you know that we need to make sure that we subtract something out here. And let's go with number 6 here, an even, or a multiple of 5 from 1 to 12. And will any multiples of 5 be even? I'm not writing them out, but I sure think so, because this is the part I want you guys to work on now. Okay, pause there if you need to. All right, choose a marble from bag. 5, 3, 5 orange, 3 green, 2 blue. All right, so let's go with a green, then a blue. So make sure you get your grand total, 5, 8, 9, 10. So probability green, then times a blue. Okay, oh, careful, without replacing. I gotta make sure I read the problem too. So we'll get you set up here. So green and then blue, figure those out. And then the very last one, orange, both orange. So again, make sure we lower that denominator because we are not replacing the first one. All right, we'll check out your answers, look for feedback, and we should be in good shape.